If you think about it, we are all doing it. We are all dealing with chemistry. Transformation, combination, change. That's all life. Except that in the research laboratory, you can study these changes. You can observe, understand them at the atomic scale. Every day you create, you transform, you combine. Chemistry is like art. You need to be creative. Hello, I'm Alex. I'm a chemist. I'm working in a research laboratory. Usually when people ask me about my job, I don't know exactly what to talk about. I'm preparing solutions using chemicals, solvents, glassware, and cool stuff like liquid nitrogen? Not much. I could go just a little further and I will directly be more specific. Talking about my research, about the nature of the molecules I prepare. I can always talk about weird experiments, some fun reactions when you mix a strong acid with peroxide. Or, less impressive but more relevant, I can talk about the materials, the molecules I synthesize. However, I never really wanted to be more specific about my research topic. Not because people wouldn't understand, but I won't be able to explain the aim of my research in a fascinating way. I can't say I was really chemistry enthusiast at the beginning of my career, but I was good at it. So I finally liked it. And here I am. Still, when you invest time and curiosity into the research field, you are not just doing your job, but you are learning every day. And now I feel much more enthusiastic about my work, about my objectives. I won't say my research is such a big deal, it will change the world. Some people will say so. Instead, I prefer to say that being able to synthesize, to create new stuff, to try different ways, keeps me going. Now, after some years learning and seeing what we can achieve, I can say chemistry is fascinating. And it's not that far from our everyday life. Then, let's talk about chemistry now, its definition, its purpose. Actually, chemistry is pretty easy to define. It's all about energy and change at any scale, either microscopic or nanometric. Take a look down to the atomic level. Electrons. Electrons are energy funnels for the atom. They can absorb energy from the outside, so they can move inside the atom to a higher energy level. When they return to the ground state, energy is going out of the atom, but in a different form of it. For instance, we can observe an emission of photons, light. UV, X-ray, microwave, infrared, all of them are photons, but with different energies. One element, one energy level. You select one specific element, you get one specific energy. Elements, all described, classified by their number of electrons inside. For each different properties, different names. Carbon, nitrogen, potassium, cobalt, iron, ruthenium. They want to interact, to exchange energy. They want to share their electrons, so they move, they combine to each other. Finally, they create bonds, they make molecules. Molecules with low energy means stability. Molecules with high energy means reactivity. Molecules with incredible properties. Luminescence, electric current, magnetism. They interact. They can transform one energy to another. Light, heat, oxidation, catalysis, batteries, solar energy. Yes, you get it. Everything is all about interactions between molecules. All about energy, which is given, taken, transformed. It's all about change, chemically controlled or natural changes. With chemistry, we make use of these interactions. We investigate to find the best conditions so we can control what we wish to achieve. That way, we can create molecules. We can bring a new way, something that nature couldn't give. The missing link. Look at chirality. One molecule and its mirror image. Same aspect, same formula, but they are not the same. They are enantiomers, like hands. One left-handed form, one right-handed form. Life on Earth is chiral. The helicity in DNA is right-handed. In nature, amino acids are always left-handed. So what about the other enantiomers? With chemistry, we can synthesize both. We can compare synthetic ones with natural ones. With chemistry, we can explore the other side of the mirror. We create a new path. We synthesize new molecules, pure compounds in very different forms. Liquids, solids, films, and eventually, we can obtain crystals. Molecules ordering in 3 dimensions. It becomes matter, the purest form of it. Organic, mineral, metal, hybrid, pure materials based on chemistry. In the lab, we deal with another world, trying to make everything possible. But don't fool ourselves. We try, but we don't decide. We make, but we don't really control. Life decides. Matter controls. Not us. We can try to explain, we can try to improve. But at the end, one unconditional truth. Chemistry rules.